Alrighty guys, what is up? Stay Daddy here tonight, and today we'll be going to be talking about Neo4j querying. Specifically, I have an example I want to go through and try to look at most of the basic querying that you're going to see or you're going to need. So all I've done so far is I've downloaded Neo4j, Neo4j desktop. I have loaded in a pre-existing database or pre-existing data that Neo4j has publicly available, fixed a couple of errors with it, and now we are just up in a Neo4j browser ready to go. So just as a summary, again, I created a new DBMS and opened up the Neo4j browser with that, and that's here. And then I went through this play listings, which loaded all of it, or explained how to load all the data. And then now I have the schema that you see here. So if you want to replicate what I'm doing, you can go online and you can type Neo4j example datasets, and you can click on either one of those links and scroll down to where it says other guide examples, and then you can choose any one of these. We're looking at this play listings example, which is a pretty good chunk of Airbnb data that we're going to be looking at today. So I like it because it's realistic. It's more of a large scale data set, and it gives us some good interesting questions to ask about the data. So there we go. All right, so before I get started here and we start querying, I just wanted to say that I think Neo4j is a wonderful tool and a wonderful resource as a data scientist. Using graphs to represent data, I think in a lot of cases makes more sense than the traditional relational approach, especially if you are looking at how your data relates to or how pieces of data relate to each other, and you have potentially a large amount of joins or large amount of relationships you're going to be looking at. That's the data that really makes sense for graph databases. And as you can imagine, Airbnb kind of fits the bill for that, right? So this is a really simplified schema. And if we look at the initial schema that they gave us, it's quite a bit more complicated than, let's just expand this out. It's quite a bit more complicated than what we have. They have a lot more things going on. I'm sure it's not as complicated as their real data set is, but we're looking at a small subset of all these nodes and relationships here. So this is what we were supposed to have, and this is exactly what we ended up with. So I'll go through another video on how to load Neo4j, download it, and then create your own data set, either manually or through a dump file or a lot of these other methods. But for today, I just really want to focus on the querying, so I skipped a lot of that. So okay, so what we have here is we have the user, or a user node, which can write a review, and the review reviews a particular listing. A host can have a listing, or host can, I guess, make a listing, host a listing, I suppose. And then a listing has a particular amenity. And then finally, the listing can be in a particular neighborhood. So this simplified data set allows us to ask some really interesting questions. So let's start with one of the first ones, or some of the really basic stuff. So what if we want the total number of listing nodes? And before we actually go there, what you can do too is you have the option to see how many total nodes and how many total relationships you have already in the browser. So that's just a nice way to quickly tell the overall summary of how large your data set is. And then, for example, you can do stuff like if you wanted to look at just a sampling of neighborhood nodes. Well, you can click on neighborhood, and then you can say, oh, okay, here's the Clarksville neighborhood, neighborhood ID, whatever. Or maybe you wanted to look at listings, for example. You could click that, and you could see what the properties are and just kind of do a little sampling. But I find this particularly useful, just as a quick way to not have to write a query out, just to see what a couple of nodes look like. So anyway, just wanted to mention that. And you can do the same thing for relationships. It'll go ahead and spell some of those out so you can see what nodes are involved, and just get an idea of what it looks like visually. All right, so with that aside, let's jump into the first query. So like I said, we want to find the total number of listing nodes. So for convenience, I'm going to go ahead and copy and paste the commands I've already worked up, and then we'll talk about them, and then I'll make changes as I want to explain other things. So first thing that we're going to talk about here is this match in listings return count. So what this means is we're going to match nodes that are of type or have the label of listing, so all of these kind of nodes, and then we're going to return the count. So we're going to return the total count of that nodes that fit this requirement. So if we run that, there we go. That makes sense. That's exactly the number we uploaded. So this all checks out. But let's say, for example, we want to see a couple of these nodes. So we could change that to n, and then I'm just going to put a limit here for brevity, because I don't want to return 5,000 nodes at once. So we'll say limit 5, and then we can return some more. And another thing to note is you can look at it graphically, or you can look at it as a table of JSON objects, or I guess JSON text, but these would be objects, if they were looking at it from like a programmatic standpoint. I'm not gonna be honest with you, I don't know. Oh yeah, okay, this is, I guess, just in text form. And then, okay, yeah, I guess this is the query object like I was talking about. So this is from a code standpoint. So anyway, I normally just use these two, to be honest with you. So anyway, we've now returned the actual nodes themselves. So rather than the count, we've returned the nodes, and we can look at each of the properties that are inside of those, and so on and so forth. So pretty simple here. And now let's look at, and just to, I guess I should mention as well, you could change this, and you could say review or host, or so for example, just for clarity, you can say host, host, and it will return 5 hosts. So you guys get the idea here. So all right, now let's say that we want to find the total number of relationships between review and listing. So we want to find all of these relationships that exist. So let me clear that out. And this is actually interesting, because this is going to, I think, help us understand some of the flexibility that Neo4j offers. So in this case, we've said, okay, match this node. So we've said this parentheses here in this case mean a node. So match a node that has a type of review, or that has a label of review, with any relationship, doesn't matter, just any relationship called R. And these variables, so A here is the variable name that holds this particular node, R is the variable name that holds this relationship, and then B is the variable name that holds the ending node. And then you also can specify a direction here. So you can say, okay, we only want it going this way. And you could do the same thing going the other way, and you could do it, just with no arrow and have it be bidirectional. So, some pretty interesting functionality there. But basically all we're saying with this query here is match a node, or match the starting node with any relationship and the ending node. But the starting node has to be with a label of review, and the ending node has to be with a label of listing, and then store all of those values. The relationship is R, the first node, starting node as A, and the ending node is B. So I really wanted to make sure I drive this point home, because this is the basic structure we're going to be using for more complicated queries coming up. So you need to understand, how all this works before we can build on this. So okay, so without further ado, we're going to match this number of relationships, and we're going to return the count. So okay, so there's 63,000 almost relationships between review nodes, and listing nodes. Okay, cool. So now we've been able to understand that. But how might we query this differently? Like, what if we wanted to ask the same question, but we wanted to structure this query a little bit differently? What we could say is, all right, we know that in this case, if we have a review node and a listing node and we want the relationship between them, the only possible option is reviews, because there's only one relationship that goes between. Similarly, we can say we don't care what the starting and ending node, what the types or what the labels are, but we want to specify that we only want the reviews relationship. So we should get the exact same number, and we do. Another thing that you could do is you could say, okay, instead of returning the relationship, we're going to return B. And since we're looking at the relationship between A and B, this number of starting and ending nodes should match the number of relationships. So we should get the same number. So you see how even a simple query asking, what are the total number of relationships between reviews and listings, can be queried quite differently and very flexibly within Neo4j, which is it's a really nice feature. Sometimes it actually is overwhelming because it's hard to understand how exactly you should write a query because you have so much flexibility. But anyway, once you get more familiar and more comfortable, it's a really good feature to have. Okay, so I think that is sufficient for that example. So now let's move on to some more interesting questions. Let's find the number of listings in a neighborhood or a particular neighborhood under a certain price. So, for example, we want to say, all right, we know there's a relationship between listings and neighborhood. We want to find everything in some particular neighborhood that is below a particular price. And price is in the listing. There's a property of listing, and neighborhood is its own property, or has a property of I guess where it is, if that makes sense. So so anyway, the query is going to look like this. Oh, and actually, so I changed this query to be a little bit more complicated so I could show how to use conjunctions in your the argument of your where statement. So so same structure here. So same matching and specifying the relationship that we're interested in. The only difference now is we're adding the where constraint. So we want where B, or where this node, so where the listing node, the price is less than 100, and also the accommodation property is greater than 4. So we want the particular situation in which all the listings that have this relationship to neighborhood, or are in this neighborhood, where for a listing the price is less than 100 and we can accommodate more than 4 people, which is a perfectly valid query, and you would probably do this all the time in real life with the filter option. If you were on Airbnb, people would be asking questions like this all the time. So it's kind of why I picked this data set, because it allows us to ask some really natural questions. So anyway, let's see what returns here. So in this case, there are 109 options that fit this bill. So, and just to show you that a little bit more concretely, let's set a let's just return B, and let's set a limit of 5, and let's look at those. So as you can see, the price is less than 100 and it accommodates more than 4. Price is less than 100, accommodates more than 4. So you guys get the idea. So the query was successful, and we were able to execute what we wanted to execute and get the results back that we were interested in. So let's, we can just leave that as is for now. Let's just take away this statement. So for example, you can have as many and clauses as you want. This, you could also substitute this with or. Use whatever conjunctions here that make sense for your use case. And then you can also just have a single query or a single argument, and then and we'll change it back to count so that you can see the difference of the more general query. So yeah, it just returns 1500 versus the other 100. So anyway, just wanted to show how you can make a compound arguments here when you're using the where clause. All right, now let's go a little bit more complicated now. And let's ask this question. So let's say, let's find the 5 cheapest places in a particular neighborhood. Which, I mean, you know, for me, I do that all the time. I want to know what the cheapest places are in a particular area that I'm looking to stay. So we can do that. Oops, sorry, wrong one. So we can do that with this particular quote. Okay, so in this case, we want to match a particular relationship. In this case, we want to match listing and neighborhood. And notice in this case, I've put in all of the parameters just to kind of really spell out what we're doing. So, but you don't have to specify. Like I could leave, you know, this off and just say A. I could leave listing off and just say B. And this relationship is sufficient to specify what we're interested in here. But just for the sake of making it more readable, I included everything here. So, anyway, what we're doing here is we're returning all of the objects, so nodes and relationships related to this relationship here, or these 3 things: node, relationship, node, or node, edge, node, I should say. And then we want to order by a particular object. So we care about node B, or in this case the listings price. So we want to order by that. We want to order by it in ascending order, and we want to take the top 5. So basically that will give us the top 5 cheapest places, or I guess I should say the as far as price goes, the lowest 5 places as far as related to price. So anyway, there we go. And so you can say that's 14, 14, 14, 14, and 0, interestingly enough. So these are the 14 cheapest places. And you know what, so I don't even know what neighborhood this is in. I just kind of chose some of these randomly. So let's return A and B so we can see the neighborhood. Okay, so oh, I said in a particular neighborhood, didn't I? Oh, okay, so you know what, I didn't specify. So this is a good example. I didn't check the quote all the way through, or the query all the way through. So we're actually looking at the cheapest. We're looking at the cheapest listings globally, and then the neighborhoods that they're attached to. So ironically, that the 4 listings are attached to the same. Or 4 of the cheapest listings are attached to the same neighborhood. So that's actually kind of interesting. But if we wanted to fix this query, so I guess that's a happy accident. If we wanted to fix this query, what we could do is we could specify here where neighborhood, or sorry, where is neighborhood? Neighborhood is A. So where A dot I think ID. A dot I think it's location. Hold on, let's check. So neighborhood, let's see what the attributes are. So yeah, neighborhood ID, or you could search the ID of the node. So we'll just use neighborhood ID. So where neighborhood ID equals, and this is another thing to be, so that's a number. Sometimes there'll be strings. Actually, let's double check. Nope, it is a string. So we need to type this in as a string. So it's another thing to be careful of. Sometimes these will be strings and not numbers, and you'll be like, why is my query not working? And it's because you're querying for an integer, not a string. So anyway, so let's look at these 4. Let's return. So let's just use this neighborhood ID. Okay, so now in theory, we should return back just these 4. There we go. Well, now we're going to return back 5 that are related to that particular neighborhood, because we were returning the top 5 across everything before, and now we're returning the top 5 across this one particular neighborhood. So the query is correct. But anyway, that's how you would change this up, so that you can make the correct query. And it's always good to print everything out, or to return everything, so you can see some minor mistakes in your queries, kind of like that. So it's a good accident, just to show you that you got to be careful sometimes to check that you're actually returning what you think that you are, what you mean to return. So, and another thing, as you'd probably notice, these can be uppercase or lowercase. It doesn't really matter. Just sometimes it's easier to read if you make your keywords uppercase. Okay. So that was a pretty good example, I think. Let's do a couple more. So this is an interesting one. So let's find the most reviewed listing. So I don't know about you guys, but whenever I shop on Amazon or other sites, I like to find not only the best reviewed things, but the things that the most people have reviewed. So I'm looking for the most reviews and the best reviews. So in this case, we don't have access to good or bad reviews, or we could use both those as query parameters, but we can figure out and use how many reviews have been placed, or have been written, I should say. So let's look at that. Okay, so starting again with the same structure. So we're identifying which relationship we're interested in. So this one here. And now we're doing something different. We're returning, as you've seen before, you can return multiple parts of your match or your query, because you're actually saying, hey, I want you to match, really what you're doing under the hood, and I don't want to get too technical, but you're matching graph structures. So you're saying, hey, this is the graphical structure that I want to match, and here are the parameters associated. And then you're returning this whole object. So this whole piece is being returned as an object. So you can look at this piece, you can look at the relationship, you can look at this, you can look at all of them together. They're just objects that are being returned that match a particular format. So you can really ask in return any of those pieces that you want. So in this case, we're returning B, which is the listing, and then we're returning the count, so we can actually aggregate across what's being returned. So for example, they're returning 1, and then there are multiple reviews associated with each listing, so we can aggregate across those particular reviews, or those reviews associated with a particular listing. So anyway, we can aggregate and then save it. It's basically saying, hey, save this as the variable num reviews, and then we can order by this variable, so order by number of reviews, and then we can, in this time we're going to go descending, and then we're going to take the top 5, so that's going to give us the top 5 globally listings with the greatest number of reviews. So so let's just for speed's sake here, the top number of reviews was 314. So okay, there was a tie, 313. So that's actually, it's pretty impressive. It's quite a lot of reviews for one particular place. So if it were me, this would be a place that I would be more apt to consider. Okay, so this was kind of a precursor query. So being able to use the relationships, so one node will have many relationships, so being able to use the relationships to ask questions about another node. And then now we're going to pack all of that together in oh no, I didn't save my super complex one. Oh, that's unfortunate. I might add it to a later video, but anyway, for the sake right now, what we're going to do is we are going to try to look at nodes across multiple relationships. So for example, what if I want to know listings and how they relate to users? That's two relationship hops, or two hops, you could say, away from one node to the other. So let's just say, for example, since we're on this, we've asked the question, what are the listings that have the most reviews? Well, let's ask now, has the same user made multiple reviews on a single listing? So for example, what if maybe this review has so many reviews because the same user has gone back and reviewed multiple times? So let's make sure that that's not the case, or see if it is the case. So the way that we would do that is the following query. So very similar to all the things that we've been doing, but now instead of specifying a hard number of relationships, or just, so I guess I could say specifying one relationship step, this *2 specifies we want to know everything that is within 2 hops or 2 relationships of this particular node. So what we should be able to do is we should be able to say, okay, we're interested in all the listings that were associated, or we're interested in only this listing. So this listing with the ID of 5456, which is the one with the most, or I guess the one that's tied for the most reviews. And then we want to see how many users have written a review. In theory, it should be the exact same number of reviews that we have, which I think was like 314. So anyway, let's run that. Okay, cool. So that means that every one user has written a review. So by default, we now know that there is no user has written more than one review. But what we could do, just to double check, is we could say the following. We could add distinct, and this will say, okay, we only want unique nodes. So for example, if there were same users or multiple of the same users that had written reviews, then they would only be counted once. So in theory, this would be lower than this number, and that would let us know that there has been some overlap between users writing reviews. But in this case, we know it's going to be the same. So, that should be no surprise. All right. Now, what I'm going to do is I'm going to pause this video, and I'm going to try to remember what my super long example was and recode it real quick, or type it in real quick, and then I'll start the video again and explain it. Alrighty guys, sorry about that. So I just figured out or wrote a similar query to the one that I had before. So let's take a look at that here really quick. So this, parts of this are going to look really similar to all the things that we've done. So we've just basically taken a lot of the stuff we've done and sandwiched it together into a more complicated query. So one thing before I start going through this, I want to bring your attention to is, if you'll notice here, there's not a variable in front of in neighborhood. So you actually, if you're not going to use, you don't need to store this relationship, this object of relationship. There's no point in putting a variable here. You can just leave it blank, and then you're going to specify what the type of the relationship needs to be. So just wanted to make you aware, and you can do that again. You've already seen the same thing for the nodes, or similar, where you just put the variable and node type. So again, it's flexible. So just wanted to make you aware. Anyway, let's start looking at this query. So in this first statement, we're basically saying we want all the listings in a particular neighborhood. So the neighborhood is St. John's, so that's pretty self-explanatory. And then we're storing, like we talked about, this listing variable in A, and then we're going to recycle it. We're going to say, okay, the neighborhood's not good enough. We want to have specific amenities as well that we're interested in, and we have to have a hot tub. that's the that's the end all be all for us, is having a hot tub at our Airbnb. So we're gonna make sure that we find all the things that have hot tubs as the amenity. So anyway, we're gonna take the same listings that we just called out for only being in the St. John's neighborhood, and we're going to say, okay, now we have to have a hot tub, and we're going to say that again in A. So now at this point, A is only things that are in St. John's and have a hot tub. And then finally, we're going to do the same thing we did before, and we're going to look for the ones that have the most reviews. And this should look, this is a copy and paste of what we did in the earlier part of the video. And then we're saving this again in A, and then we're returning A, B, C, and then the count of D as the number of revs. And then so we can see graphically, we can see A, B, and C. So we can say that, okay, of the top of the nodes that fit these qualifications and have the top reviews, these are those nodes. These fit all the bills. So as you can see, each of them has a hot tub, and each of them is in St. John's. And then if we look, we can also see that they had the highest number of reviews in descending order, just like we asked. And this should give us a nice list where we can pick our favorite Airbnb with that beloved hot tub. All right, so that's it for this query, and this is really this is starting to get into the more advanced querying, and chaining match statements together can allow you to, and will allow you to ask some pretty complicated things of the data. And in subsequent videos, I'll do some even more advanced querying where you can do subquerying with the call function, and you can really start to do some interesting things. That you can use APOC, which is a library to start doing in degree and out degree, and looking at for each and looping through different nodes, and doing all sorts of interesting things that really give you a lot of tools to tell a story with the data, which is what we're ultimately all trying to do. Anyway, finally, I just wanted to touch on this brief kind of syntax, or I guess different styling. So I don't normally write this way. This is why I didn't include it earlier, but I just wanted to make you aware that you can, if it's interesting to you. So this is a similar match statement that we had before, where we are asking for a particular neighborhood, but rather than using a where clause, we're now just going to use these curly braces, and we're going to specify the property and then the value of the property that we're interested in. And basically, so all of these 5 nodes are in the St. John's neighborhood. Whereas before we would have used the where statement and said where, b.name equals St. John's. I typically don't write, even though this is more succinct and probably a little bit more elegant, I don't write this way because I like you can chain things together with a where statement. You can use greater than, less than. It just gives you more flexibility. So I typically write that way. And you may be able to do it this way, but I just have never bothered to try to figure it out. So just want to make you aware that this exists. So if you see it, it wouldn't confuse you. And then if you want to look into it more, by all means. Anyway, guys, this has been a long video already, so I'm going to end it here. But I really hope that you got something useful out of it. And I really hope that you guys have a great night, and join me again for the more advanced querying. Thanks, and have a great night. Bye-bye. All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear, or if there's anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.